Today we're looking at section 8.3, division properties of exponents. I have a couple things we're trying to get done. We're using division properties of exponents to evaluate powers and simplify expressions. And we're using division properties to find probabilities. First thing, we got a couple of rules that go along with it, or the properties that go along that are associated with division. Let A and B be numbers and M and N be integers. First thing is a quotient of properties, or the quotient of powers property. To divide powers having the same base, subtract exponents. Just like last week when we had the same bases that were multiplying by each other, x to the second times x to the third, we added the exponents. That gave us x to the 2 plus 3. Now we're dividing the same bases, and multiplication goes with addition. Division goes with subtraction. So here's an example here. A to the m over a to the n. Notice the bases are the same. Both of them are a. You subtract m minus n, your exponents. So you get a to the m minus n when a is not 0. Same thing with 3 to the 7th over 3 to the 5th. Same base 3, so 3 to the 7 minus 5 becomes 3 to the second power. The power of a quotient property, we actually did a sum of this last week. It says to find a power of a quotient, find the power of the numerator and the power of the denominator, and then divide. Here's an example. It says a over b to the m. You go ahead and do what we were calling, and weren't calling it quite right, but we were calling it to distribute. A to the m over b to the m. A to the m over b to the m. So if you have 4 over 5 to the third, you would do 4 to the third as your numerator and 5 to the third as your denominator. Here's example number 1. 8 to the 4th over 8 to the 3rd. Notice the bases are the same. Both of them are 8. So you do 8 to the 4 minus 3. That leaves you with 8 to the 1, or 8 to the first power. And 8 times itself one time is simply 8. Same bases, subtract the exponents. Negative 7 to the 5th over negative 7 to the 5th. Same bases. So you have negative 7, notice that stays in parentheses the way it's written, to the 5 minus 5. 5 minus 5 is 0. So the fact that it's negative 7 is irrelevant. It becomes to the 0, and anything to the 0 we all know is 1. C says 5 to the 3rd times 5 over 5 to the 5th. 5 to the 3rd times 5. Now it's taking a little bit of what we did last week, multiplying the same bases at the top if you don't even look at the bottom at all. If you just look at 5 to the 3rd times 5, it's like 5 to the 3rd times 5 to the 1st, which gives you 5 to the 1 plus 3, and that's where 5 to the 4th comes from. Now you have 5 to the 4th over 5 to the 5th, so you do 5 to the 4 minus 5, which is going to give you 5 to the negative 1. So you have 5 to the negative 1 power. It needs to ride the elevator since it's being raised to the negative power, which means since it's at the top, it's going to go down. It leaves you with 1 on the top over 5 to the positive 1, which is going to be simply 5 for that one. 1 over 5. And then the last one from example number 1 says 1 over x to the 7th times x to the 4th. Remember, everything's considered to be over 1. So when you multiply straight across, 1 times x to the 4th gives you x to the 4th over x to the 7 times 1 gives you x to the 7. Now notice you're dividing the same bases. Both of them are x. So you have x to the 4 minus 7, which gives you x to the negative 3rd. That needs to ride that elevator down. When you have x to the negative 3rd, everything's considered to be over 1. So take that x to the negative 3rd. It goes down. It becomes positive. 1 stays at the top. X to the positive 3rd. Example number 2 is using the power of a quotient property. So just like last week we had 2 to the 3rd squared, we're raising a power to a power. So instead of adding the exponents last week, in this case, you would do 2 to the 3 times 2. You would multiply the exponents. So right here we have negative 8 over 5 to the negative 3rd. And again, we did stuff like this very similar last week. You would take negative 8 over 5, and notice all this second step is from this one to this one is just showing you that the negative is either on the 8 or the 5. They just brought it to the top like most of the time I always show you. And you're going to give on the next step, you're going to give negative third power to both of the numbers, negative 8 to the negative third and 5 to the negative third, which means they're both being raised to the negative exponent, so they both need to ride the elevator. Negative 8 to the negative third goes down, and 5 to the negative third goes up. So you have 5 to the positive third on top and negative 8 to the positive third at the bottom now. Everything stayed the same. They just went from top to bottom and bottom to top. So 5 to the positive third is 125 over negative 8 to the positive third. If you need to look at this step here, it's just negative 8 times itself 3 times. Notice a negative times a negative. The first one will give you a positive 64, and then when you multiply that by another negative 8, it goes back to being negative, in this case 512. And then they just move the negative back out to the front of the property for you. So back to the front of the fraction. Negative 125 over 512. That's simplified for us. Example number 3 is simplifying expressions. Now it starts to look confusing. It's really not. It's really not. You multiply straight across. There's actually a step that can simplify this for you a little bit. You can cross cancel if you notice that the number 4 and 12 have a common factor. They both have the number 4 go into them. So if you cross cancel 4 and 12, 4 times 1 gives you 4, and 4 times 3 gives you 12. That actually makes your numbers a little bit smaller. And you can multiply 3 times 3 instead of 3 times 12. So you would get 9 when you multiply those bases by each other. And when I mean 3 times 3, your bases or your coefficients in this case, 3 times 3 will give you 9. Then you multiply x to the first power times x to the third power. So that's x to the 1 plus 3. And this is all we're looking at the top. We're looking at the numerator. And y to the fourth power times y to the second, which gives you y to the 4 plus 2. That's all of the numerator. The bottom, you have 1 as both of your bases, so 1 times 1 will give you 1. And x to the 3 times x to the second gives you x to the 3 plus 2. So it's a bunch of little things that when you combine them gives you 9, back to another color, 9 to the x, 9x to the 1 plus 3 is x to the 4th. Y to the 4 plus 2 is y to the 6th over x to the 3 plus 2 is x to the 5th. So the only thing we have to do left at this step is do x to the 4 minus 5, since right here, notice, we have the same base that we're dividing, and that's what we're doing today. You subtract the exponents. So you have 9x to the 4 minus 5, y to the 6th. There's no more x to the 5th at the bottom because we subtracted it already. That leaves you with 9x to the negative 1, y to the 6th. And you can't have a negative exponent just like before. This is being raised to a negative power, so this rides that elevator down, and it leaves you with 9y to the 6 on top and x to the first power at the bottom, or simply x at the bottom. So again, just to recap this problem, since it's involved, if you don't cross cancel it right away, it's okay. You'll just deal with bigger numbers along the way. Multiply everything you can multiply out. Multiply 3 times 12, your coefficients, that gives you 36. Multiply 4 times 1, those are your coefficients, gives you 4. Then divide 36 by 4, since that's what it says, and you get the number 9. On the top, multiply your x to the first power times your x to the third power, that means 1 plus 3, and multiply your y to the fourth power times y to the second power, that means 4 plus 2. At the bottom, do x to the third power plus 2. And here's the second one from that one. It says 2x squared y to the third, all of that being raised to the 5th. So if you distribute that, this just separates it for you and says 2x squared to the 5th over y to the third to the 5th. So that just puts the 5th at the top and the bottom for you. You still need to distribute 2 to the 5th and x squared to the 5th. So that gives you 2 to the 5th. X to the 2 to the 5th means x to the 2 times 5 over y to the third to the 5th is y to the 3 times 5. So 2 to the 5th And that's that step there. 2 to the 5th is 32. That means 2 times itself 5 times. X to the 2 times 5 gives you x to the 10th, and y to the 3 times 5 is y to the 15th. There's no more negative exponents, so there's your simplified version. Then we have a checkpoint 4 to the 7th over 4 to the 4th. Same basis. So you would do 4 to the 7 minus 4 is 4 to the 3rd. That means 4 times itself 3 times, which is 64. Notice for number 2, both of your bases are negative 7. So negative 7 to the 8 divided by 8 is 8 minus 8. That's negative 7. That's still parentheses. Negative 7 to the 0 power. Negative 7 to the 0 power. Anything being raised to the 0 power is actually, that is a parentheses mistake again. I'm wondering why I put that there. The reason it becomes negative 1, let's look at why it's going to give you negative 1 real quick. The reason it's negative 1 is because it's negative 7 to the 8 minus 8, which is negative 7 to the 0 power. This is the only thing that's being raised to the 0 power, 7, not negative 7. Anything to the 0 power is 1, and your negative comes down in front of it. It's a very common mistake. You can see I just made it for you just now. Number 3 says 2 squared over 2 to the negative 8th power. Same basis. That's 2 squared minus a negative 8. Notice we have minus a negative right there, just like it always is. That acts like that. 2 plus 8. So 2 plus 8. 2 to the 2 plus 8 is 2 to the 10th power. That means 2 times itself 10 times. 1,024. And then the last one on the first checkpoint, 3 over 4 to the 4th. And we did something similar to this last week. 3 to the 4th over 4 to the 4th. 3 to the 4th means times itself 4 times, which is 81. And 4 to the 4th means 4 times itself 4 times, which is 256. 81 over 256. In the second part of the checkpoint, 2 over y squared to the 6th says simplified expression. Make sure they have no negative exponents. 2 to the 6th. 2 to the 6th over y squared to the 6 becomes y to the 2 times 6. So 2 to the 6th power is 2 times itself 6 times. That's the number 64 over y to the 2 times 6 is y to the 12th. Remember, everything's considered over 1. So if we do this, we have 2 times x to the 5th gives us 2x to the 5th over 1 times x to the 11th, x to the 11th. Notice we have the same bases. Both of them have x. X to the 5th over x to the 11th. That leaves us with 2 that's still there, x to the 5 minus 11. Remember, division goes with subtraction. So that gives us 2x to the 5 minus 11 is x to the negative 6. Notice at this point, only x is being raised to a negative power. So only x is going to ride the elevator down. 2 is going to remain on top. So you're going to have 2 over x to the positive 6 power. And then there's this great big looking involved problem at the end. It's not really as intimidating as it looks, especially if you realize right away that the number 6 and the number 24 have a common factor. The number 6 goes into both of them. 6 times 1 gives you 6, and 6 times 4 gives you 24. So now you're dealing with much smaller numbers. Multiply the coefficients. 5 times 4, and you get the number 20. Multiply your x terms, x squared times x to the 5th. Since we're multiplying, x to the 2 plus 5. Remember, plus goes when you're multiplying. And do your y terms. Y to the 3rd times y squared means y to the 3 plus 2. That's your entire numerator. Your denominator, we just have 1 times 1 that's not shown, so that'll just be 1. And x to the 4th times x to the 6. That gives you x to the 4 plus 6. Remember, multiplication goes with addition. And the only other thing they have up there is y to the third. So we'll just bring down y to the third. At this point, we could just simplify everything we have. 20, x to the 2 plus 5 is x to the 7th. Y to the 3 plus 2 is y to the 5th. Over x to the 4 plus 6 is x to the 10th. Y to the third. So let's simplify the last step we have. We have the same bases being divided by each other, x to the 7th and x to the 10th. So that's going to give us, let me move it a little bit. X to the 7th and x to the 10th is going to give us 20. We still have 20 there. X to the 7 minus 10. And y to the 5, y to the 5th over y to the 3rd gives you y to the 5 minus 3. It's going to get a lot shorter in a second. 20x to the 7 minus 10 is x to the negative 3rd. Y to the 5 minus 3 is y squared. Notice the only thing that is a negative exponent here is x to the negative 3rd. That's the only thing that rides the elevator. It's at the top of the fraction since there is no fraction present. Remember, everything's over 1. It's going to ride the elevator down. 20 is still at the top. Y squared is still at the top. And x to the negative 3rd becomes x to the positive 3rd. So 20 is still at the top. Y squared is still at the top. X to the 3rd goes to the bottom.